Welcome to Mattermosaic, piecing together the universe one discovery at a time. Today, we're exploring one of the most urgent questions of our age, the science behind climate change. What's really happening to our planet, why it's happening, and what it means for the future of life on Earth. For most of human history, Earth's climate has been remarkably stable. The seasons came and went, the oceans held their rhythms, and ice and warmth balanced each other in a delicate dance. But over the past century, that balance has begun to shift in measurable and unmistakable ways. Average global temperatures have risen by more than 1 degree Celsius since the late 1800s. It sounds small, but on a planetary scale, it's enormous. Ice sheets are melting, sea levels are rising, and storms are becoming more violent and unpredictable. The atmosphere now contains more carbon dioxide than at any time in at least 800,000 years. Every ton of carbon we release acts like a blanket, trapping more heat that would otherwise escape into space. The story of climate change begins with something invisible, the greenhouse effect. When sunlight reaches Earth, part of it is absorbed by the land and oceans, warming the planet. The rest is reflected back into space as heat. Gases like carbon dioxide, methane, and nitrous oxide trap some of that heat, keeping Earth warm enough for life to exist. Without them, our planet would be a frozen desert. But human activity, burning coal, oil, and gas, clearing forests, and industrializing agriculture, has thickened that blanket. More heat stays trapped, and global systems begin to shift. The oceans warm, ice melts, weather patterns destabilize. The greenhouse effect itself isn't new, but humanity has disturbed its balance. We have turned up Earth's thermostat. Scientists have tracked the fingerprints of this change across every corner of the planet. Glaciers are retreating on every continent. The Arctic's sea ice is shrinking at a rate of over 10% each decade. The oceans, which absorb more than 90% of the planet's excess heat, are becoming warmer and more acidic. Coral reefs, home to a quarter of all marine species, are bleaching and dying. And across the globe, storms grow stronger, droughts last longer, and floods arrive with greater force. The most compelling evidence comes from ice itself. Deep within the polar caps, scientists have drilled cylinders of ice that preserve tiny bubbles of ancient air, a record of our planet's atmosphere stretching back hundreds of thousands of years. Those frozen records show that carbon dioxide and global temperature rise and fall together, and both are now climbing faster than at any time in Earth's history. Some still ask whether these changes could simply be part of a natural cycle. After all, Earth has warmed and cooled before. Scientists have tested that question again and again, examining solar activity, volcanic eruptions, and variations in Earth's orbit. None of them explain the pace of the current warming. Only the rapid rise in greenhouse gases from human industry fits the data. Climate models that include human emissions reproduce today's temperature trends with striking accuracy. Models that leave them out do not. The verdict is clear and overwhelming. The warming we see today is primarily caused by human activity. This is not politics, it is physics. But the story doesn't end with temperature charts and data points. Climate change is reshaping the face of the planet in real time. The Arctic, for example, is warming nearly 4 times faster than the global average, a process known as Arctic amplification. As ice melts, it exposes darker ocean water that absorbs more sunlight, which leads to even more warming, a dangerous feedback loop. Meanwhile, rising sea levels threaten to displace millions of people in coastal regions. Cities like Jakarta, Miami, and Manila already experience regular flooding. By the end of this century, the oceans could rise by a meter or more, depending on how fast the Antarctic ice sheet collapses. The consequences reach into every part of life. Crops wither in the heat, forests burn more frequently, and species struggle to survive as their habitats shift or vanish. Human health is affected too, with heat-related illnesses increasing and diseases spreading to new regions. Air quality worsens and food security becomes more fragile. None of this is speculation. It's measurable, observable, and already happening. Yet climate science is not only a story of warning, it's also a story of understanding and possibility. The same science that revealed the problem also shows us how to solve it. We know where greenhouse gases come from, the energy we use, the food we grow, the way we move, build, and consume. We also know how to change that. Clean energy technologies like solar, wind, and hydro can replace fossil fuels. Protecting and restoring forests can pull carbon dioxide back from the air. Smarter cities, efficient transport, and innovation in agriculture can cut emissions dramatically. Even new technologies are emerging that can capture carbon directly from the atmosphere and store it underground. It's not science fiction, it's science in action. And models show that if global emissions peak soon and fall to net zero by mid-century, we can still limit global warming to manageable levels. It is not too late to slow the trend, but every year of delay makes the path steeper. What worries scientists most are the tipping points, thresholds that, once crossed, could trigger irreversible change. If enough Arctic ice disappears, global weather patterns could shift permanently. If the Amazon rainforest dies back from heat and drought, it could release billions of tons of stored carbon, accelerating warming further. If frozen methane in the Arctic permafrost thaws, it could ignite feedback loops that spiral out of control. These are not certainties, but they are real risks. Avoiding them means keeping global warming below 1.5 degrees Celsius, a limit set by the Paris Agreement. Beyond that point, change could accelerate faster than civilization can adapt. Sometimes the most profound truths are seen from far away. Astronauts who have looked back at Earth from orbit describe a thin, glowing veil of blue, our atmosphere, wrapping a fragile, living world. That film of air is only a few dozen kilometers thick, thinner than the skin of an apple compared to its size. Within it, all life has unfolded. Every forest, every ocean, every breath we take. To understand climate change is to understand how delicate that balance truly is. Humanity has always adapted to change, to ice ages, floods, and famine. But this time is different. The transformation is faster, and it's of our own making. Climate change is not just an environmental issue. It's a social, economic, and moral one. It affects the poor first and worst, it disrupts economies, and it challenges how we live and what we value. Science gives us the data, but what we do with it depends on who we are. The future is not predetermined. If we act with courage, innovation, and cooperation, we can slow the warming, stabilize the climate, and preserve the natural systems that sustain us. If we fail to act, the consequences will shape generations. Hotter cities, rising seas, shifting borders, and lost worlds. The difference between those futures lies in what humanity does now, within our lifetime. Our story is not ending. It is still being written, in carbon, in ice, in air. Every fraction of a degree matters. Every action counts. The science behind the crisis is clear. The question now is what we choose to do with it. This is Mattermosaic, piecing together the universe, one discovery at a time. If you enjoyed this, let us know in the comments and keep the journey going by watching our next video.